Namaste students. Today's concept computational thinking for grade 6. Chapter 2 lines and angles. Our first question. 8 friends A, B, C, D, E, F, G, H are sitting at equidistant positions around a circular table, each facing towards the center as shown in the figure. A is facing northeast, so let's draw the directions north, south, east, west. So A is facing northeast. B and D are facing perpendicular directions. Okay. So now let me erase the directions as we know. Let me erase the directions. And it's clearly mentioned B and D are facing perpendicular. Okay, let be there. B and D are perpendicular. Maybe something like this, or something like this, or it may be something like this. Okay, there should be 90-degree. Great. B is immediate left of A. So this is A, left of A is B. I'm done with the third condition, while C is exactly between E and F. Okay, we'll wait for this as we have no idea about E and F. Okay, so now the next condition is that B and F are facing opposite direction. Done with F. So I want to go with E and C. In that case, I don't think so I can give D here. I mean E here. I can't give E. Let me wait for the next condition. The next condition is if G is sitting exactly between B and D. Great. So this makes it very clear. G is between B and D. So B is here, then G is here, obviously D is here. Hope it's clear. Then what is the next condition? What are we supposed to fill? A is done, B is done. I'm supposed to go with C is exactly between E and F. Okay, since E is between, I mean C is between E and F, I can't give C over here. So if this is C, then this is E and the left out is H. What is the angle? What is the angle between the direction A and C? A is here, it's opposite to H, which is 90-degree. C is intersecting it in the form of perpendicular. So obviously the angle is 90-degree. I go with 90-degree. The angle between A and C are 90 degrees. Moving on to the next question. Avi and Sam attended dance session in the afternoon. In the afternoon, okay. Avi's session starts when angle between the hour and minute hand of a clock is 60-degree. Let's consider a clock first. Okay, in that case here, what they have asked is hour hand in the afternoon. In the afternoon, I guess the time may be 12 o'clock. Correct. If it's 12 o'clock, the angle between hour hand and minute hand is 0-degree. If it is 1 o'clock, the angle is 30-degree as we know. And now it's exactly 60-degree. Great. So the time should be approximately 2 o'clock, 2 p.m. But there is, other possibilities also. It can also be, here if it is 3, then 90-degree. We are not talking about that. Let me give you another clear explanation for the same. It's not like, exactly 2 o'clock. It can also be like, 3, 5. If it's 3, 5, the angle between the hands is 30-degree. Or it can also be like 4:10. It can be 4:10. So angle between any two numbers, consecutive numbers, will be 60-degree. But for now, let me keep it as 2 p.m. Sam's session starts at 1:55. Okay, what is the least possible difference? See, this is what I was waiting for. There will be a twist. Least possible. So the least possible, obviously, it's 2 p.m. and 1:55. So the difference is 5 minutes. Moving on to the next question. An equilateral triangle is given below at minimum. By how many degrees should the given triangle be rotated anti-clockwise so that it looks exactly like the original triangle? First, let me consider the triangle, use a protractor to measure the base and the angle. This is 60 degree. The internal angle is 60 degree. Whenever you rotate the triangle, the base is what we need to concentrate with. Okay, let me move 60 degree. As you see, this is a base, right? This is a base. So the rotation starts from 0 degree and it has moved 60 degree. Do you think that is this same as the given triangle? Obviously not. So let's move a little more. Great. Yes, now it is. So I have moved from 0 degree to 60 degree. We need to check with the baseline. This is the baseline. Okay. So I go with 120 degrees. And our next question, I love this because it's going to be very simple as there are much diagrams. Here you see 1, 2, 3, 4, and here it's 90. So it's very simple, I believe. It's like 360 divided by 90. It gives me 4 partitions, 4 times. Okay. And here it is 360 divided by 120. Obviously, it's going to be 3 partitions. And here I have 360 divided by 45. If I'm not wrong, it's going to be 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yes. Then this 360 divided by 60, which gives me 6 partitions. I go with option C. 1, 2, 3, 4, 5, 6. Great. Moving on to the next question. A and B visit a park in the evening. When A visited the park, the minute hand pointed at 12 and the other hand was 150-degree clockwise from it. Let us assume a clock. Let's check that. What is this? Visited park. Minute hand pointed 12. Okay. Let me point 12, the minute hand. And other hand was 150 degree. Let me assume protractor, then 150 degree. If this is 0, 150 degree lies somewhere here. Okay. Yeah, my line is not straight, but still, it is 150, which means 5 o'clock. It is 5 o'clock, right? 5 o'clock. Since it is evening, considered to be PM. Great. And we visited the park, the hour hand at 5. Hour hand it is 5. It's the same. Let's check where is the minute hand. 100 clockwise. So, okay. So let me consider one more clock, but I need, a 360-degree protractor. I have used 280-degree protractor. Since here, from here, let us go for 210 degree. So it's like 0 will move on, move on, move on, move on, move on. This is 180, 190, 200, 210. It's pointing 12 again. So this also points 5 o'clock, 5 p.m. Great. This is 5 p.m. and this is also 5 p.m. Okay, A visited the park before B, B visited park before A and B visited exactly at the same time. Yeah, in the examination, if you don't have your protractor, obviously it's very clear, 6 to 7, it's 30 minutes. The angle between any two numbers, consecutive numbers, is 30 degree, 30 degree. Yeah, it's not 30 minutes, 30 degree. So 30, 60, 90, then 120, 150, it just goes on. Great.